cloud. So yeah, we're talking about domain routing. So like I knew every single one of my friends' phone numbers. Just I could just dial them. We had a landline phone. This is like 1999 and 2000, 2001 maybe, before I actually had a cell phone. I didn't think I got a cell phone until 2001. One of those old Nokias. And even then I still like had all of my friends' phone numbers memorized. I could just call them. I knew exactly what their number was. I knew which pizza joint had what phone number because, you know, we order pizza all the time. But now I don't. I just type their name into my contact list and say call them. So that's the kind of the equivalent of like a domain service is like I know people by their familiar names, something that's easy for me to remember, and then let my phone handle figuring what their phone number is because it's stored in there. The only phone number I know anymore is mine, and I barely know that one. Sometimes I have to ask my wife what it is.
So remember the weather number and the temperature? Just to call it.
Oh yeah, I remember that. Like
Yeah.
it would also tell you what time it is too, didn't it?
Yeah.
Time, temperature, and weather. I remember that. Now I just say Echo, what's the weather?
Yeah.
Or Alexa or whatever. I changed it to Echo because I don't want Alexa's too many syllables. Yeah, so we use a system of URLs to locate specific resources. Yeah, what's that?
So HTTP is just for web browsers, and it's basically like security.
Let's actually look at that. I've got it right here. Okay, this is a good question. So the HTTP is the protocol. HTTPS, if it's got the little S next to it, that is just, all that's saying is that your connection is encrypted. And usually when it's displayed in a web browser, this part's cut off, and it'll just show you the rest of the URL. This stuff is still there, and it's still being used, but it's kind of fading into the background where we don't have to worry about it as much. And instead of seeing HTTPS, you just see a little padlock icon usually. I think Firefox shows I think pretty much every browser shows a padlock if it's an encrypted connection. So that's the protocol. This little bit here, the : / that you've seen before, all that is Tim Berners-Lee decided we need something to go between the protocol and the rest of the address. : / It's called a delimiter. It's literally just some stuff that goes there to separate the two. He's the one who decided, basically one person made a call, decided what would go between them, and it was : / for some whatever reason. I'm sure there's some logical argument to be made for using this as our delimiter, but all it's really is it's just a convention. It's just what somebody decided. Pretty sure it was Tim Berners-Lee. So it means nothing. So HTTP : / that first part is the protocol. That is the thing. That's the language that web browsers speak, basically. Let's see here. Starting over here, the .com, that's your top level domain, and there's so many of them. Like, what other ones can you guys think of?
Isn't like .org organized?
.org. Yep. We've got LLTC. .edu. We've got actually. We've got there's actually a ton of them here. Let me see here.
.gov government stuff.
Gov. Oh yeah, .gov is government stuff. Actually, yeah, you can't own a .gov. Where is it? I had. Oh yeah. I know where to find it. Top level domains. List of top level domains. Check this out. There is so many of them. Some of them are specific to various countries, like .co.uk. That's one for England. .us, United States of America. Uzbekistan has one. So there's a lot of them that are just specific to countries. There's a lot of them that are specific to there's like words like .audio, .app, .apartments, .amazon. Amazon has its own top level domain. That's crazy.
That's crazy.
So it started out with like 4, and now there's way more. And basically, what top level domains give you is a uh, sort of a way of breaking up the phone book into chapters, kind of. So like the biggest domain by far is .com. Obviously, everything is .com, but that's kind of and that'll probably remain true for quite a while. But now a lot of people are branching out into other domains. The one nice thing about .com is it's cheap. A .com domain is $12 a year. A lot of video games like the .io, because it's kind of a play on input output and IO and all that. It's a techie thing, but it's supposed to be a domain specific to places specific to the region around the Indian Ocean in like Asia. But it's just, it's just how it ended up being. But .io domains are like $85 a year. They're really expensive for whatever reason. I don't know why some are more expensive than others, and I don't really know who sets the price. So then there's the domain. The domain I actually own, and I used Google Domains as my domain registrar. I used another website for a while, but Google Domains is just so much easier to use. So erickuha.com, which I've owned for quite a while, is the domain. That's the thing that I own. So erickuha is the domain and the .com domain, and that is that I have exclusive control over what gets displayed on erickuha.com. One other cool thing that you can do is most domain registrars will allow you to register for free any number of subdomains. So I can actually just create a new website, put something else before erickuha.com. So in this case, ITECH, which leads to the textbook. So I can I can create as many subdomains as I want, and I can delete them and recreate them at will for like other classes if I want to have like a course website or something like that. I do one for the web browsing or the web design class, and I'll do one for the for my programming classes and stuff. So this is really cool. Like you can just create your own domains totally at will whenever you want, underneath your kind of overarching domain, and it's free to create these.
Who do you pay yearly?
I guess I'm paying Google.
Huh. I would have thought like Microsoft or.
Yeah, so the used to be the case that there was like one organization that had exclusive control over domain registration. But then a bunch of big tech companies like Google, and I'm sure Microsoft has a domain registrar as well, started throwing their weight around and influencing these nonprofit organizations, and then they wanted to turn it into a business. So now Google's a domain registrar, Amazon is, there's a whole bunch of other people that are domain registrars. But they still have to nobody else can sell erickuha.com now. Only Google. Google is the registrar for this domain because I bought it through them. So there is like a central repository of who owns what domains and who the registrar is and stuff like that. So if I do like a who is lookup, who is domain lookup, let's do, the ICANN one is probably the best one to do. If I type in erickuha.com in the domain lookup, it will show that, Google Domains is the registrar and the name servers created 2015. It doesn't say my name. I have it set so that because every domain has to be associated with somebody's phone number, name, and all that stuff, and a physical address. But Google has the option where I can have that information be kept private. So registrar information, Google LLC, all that. So it's pretty slick. It's pretty easy to use. I'll show you guys how Google Domains works at one point. Everything after the /, so there's the domain stuff right here, and then there'll be a slash, a forward slash. Everything after that is the path. So everything specific to this like website is routed to is everything after it is like you're on that computer now, and then you just have to find the right file. So this is just the path. It's in the book folder, the chapter 2 folder, and this file, what is internet.html. So that's the name of the file that this page in the text is. The course text. I think that is it. It's what is the internet? So that's that URL right here. Any questions about this?
So encryption is only me and the server see what's going on?
Oh, it's so cool. It's this really weird system. So it relies on this actually unproven mathematical principle that large prime numbers are hard to factor, or large numbers are hard to factor. So you take two very big prime numbers, they're like 128, 256 digits long. They're very big prime numbers. You multiply them together, and then you get a key. And I have a different key than they have. I have a key that can encrypt it, and they have a key that can decrypt it, and vice versa. So if I can encrypt things with my key that can only be decrypted with their key, then they encrypt it with their key, and only I can and then they encrypt whatever the response is, and only I can decrypt it. Like they couldn't do it. It's really weird. It's called public key cryptography, and it's so strange. Like I took an algorithms class where the professor literally spent the first 2 weeks. I mean, like for the first 2 weeks, I was hanging on by a thread. I literally could not wrap my brain around anything he was talking about. It was so math heavy and crazy. And he did the entire proof. It took like 2 weeks, just filling the whiteboard and then going back to the other side and erasing it and filling it again, like for 2 weeks straight, as he did the formal proof of how this, or the formal description of how public key cryptography works. And I don't get it. Like, I do not understand how that math works. It is so unbelievably weird.
But I mean, I suppose that's the point of it.
Yeah, I mean, you gotta. They understand the math of it makes sense, but the weirdest part about it is we actually don't know if the assumptions we've made about it are true. We don't know if public key cryptography is actually secure. We have no idea. We think it is, but we don't know that it is.